So in this video, we'll learn about Python list. So we'll see how to create a list, how to change or remove elements within a list, and the different operations with lots of examples. But first, what is a list? So essentially, a list is a data structure, it's a data type, right? Because there are other data types in Python like sets, tuples, dictionaries, which we'll learn in separate tutorials. But in Python, a list is used to store multiple variables, multiple items in one variable. So this is the syntax over here, elements within square brackets. But I guess one thing to remember about list is that it is changeable, it is mutable. So you can mutate a list. So we'll talk about, different things that you can do with a list with practical examples. So you know how to apply it. So we'll talk about all of these elements right here. So first, how do you create a list? So syntax-wise, it's multiple elements or multiple items within square brackets under one variable. So what that means is that let's have, a variable called L1, and within that, it's a list. So this is the syntax for the list. And so within these brackets, you can have different data types. So it can contain numbers, for example, let's say 1, 5, 100, 99.9, for example. So if I print this, or you can have a bunch of strings as well. Let's say A, for example, John, for example, B. If I run this, then you have a return. It'll return the a list of strings. But you can also have a combination of different data sets. It doesn't have to be just one type. It could be, let's say L1 could be, numbers. John, a string. You can have float as well, 89.9, for example. So if I run this, I can either run it or print. Then you have 4, 5, John 89, whatever. So it returns a combination of different data types within the list. So just like any other built-in sequence types, lists can be indexed, and they can be sliced as well. So indexing means what? So the first element here, you have 4, 5, John 89.9, for example. So the first element is index 0. For example, the first element is index 0, the second element is index 1, index 2, index 3. So if you want to return like one element out of this set, not this set, out of this list, then this is what you do. So for example, L1, I want to return index 0, or the first element here, then that's index 0. So the first element is index 0, not index 1. So if you start from left to right, this is index 0, 1, this is index 2, index 3. We'll talk about negative sequence, but let's run this first. So it'll return the first element. If, for example, you want to return a last element, you can either do, index 0, 1, 2, 3. Let's do that. So L1, index 3, for example. That's 89.9. Or index minus 1. So if you start from the right, negative indexing, the last element is index minus 1. So this is this is the list. So index minus 1, index minus 2, index minus 3, index minus 4. So this is 4-element list. So indexing, positive indexing goes from 0 to 3. 1, 2, 3. Negative indexing goes from, minus 1 to minus 4. So let's say, let's create another list here. Or, yeah, let's create another list. Let's say 8, 10, Eric. Let's make it a little bit longer. 59, 99.9. Let's say A and B, for instance. So this is the 7th element list. So let's print that. So if I want to access index 3 to index 5, for instance. So index 3 to index 5. But instead of putting 5 here, it's always n plus 1. So if I put 5, let's say 5. So what's the 5th element here? So this is 0, 1, 2, 3, right? So 59 is 3. 4, A is 5. A is the 5th element, but I want to include A in it. So it'll have to be 5 plus 1. But let's print this and you'll see what I'm saying. So if I print that, it prints 3, the 3rd element, 0, 1, 2, 3, but it doesn't include A. Why? Because if you want the 5th element to be included, you will have to add plus 1. So you'll have to put 6 here, and it'll be included. So remember, a 7th element goes from 0 to 6, right? So remember that. And if I want to print the 5th element to be included in the index, then I'll have to put as the last element, as the last index, plus 1. Okay? And if I want to print from, for example, from the 3rd element to the end, I leave it just like that, with the colon. So that will start from the 3rd element, which is 0, 1, 2, 3, starts at 59, and it'll print all the way to the end. So if I want to print, this is slicing. So if I want to print the whole set as well, I just put colon and it'll print the whole set of elements, all 7 elements as well. So this will print from, the whole, it will just pretty much copy the whole list. This right here from one index and the colon syntaxing will print from the 3rd element all the way to the end. And this would be from one element, one index to another. But remember, if you want the 5th element, put a 6 here. So 5 plus 1. If you want the 4th element, put 4 plus 1 here as a, 5. So likewise, if I want to use negative indexing and I want to print, for example, from this 3rd element right here from the right, if I just want to print, for example, these 3 elements, then it'll be L1. Oh. So this is minus 3. This is minus 4 index. This is minus 5. So I'll start with minus 5. And remember, the last item should always be plus 1. So because this is minus 3, so it'll be minus 3 plus 1. So that's minus 2. And if you print that, it'll be these 3 elements right here. But if I say, put minus 3 here, again, it's only going to include this element right here. So just make sure the last element that you want always be plus 1. So always remember, when you slice list, the beginning here is always inclusive, but the the end is exclusive, if that makes sense. So just remember that. So list also supports concatenation. So let's say you want to add some elements into the list. You can just use plus and then add whatever values you want. 87, for example. Let's say, well, first of all, let's reprint L1 so we know what the original L1 is first. Okay, so if I want to concatenate this, I want to add, for example, 100 and 200. It doesn't have to always be numbers, but I think it's just easier to use as example. So if I want to do that and I run it, you'll see here that it's added, to our original L1. And you can do that in the front as well. It doesn't really matter. So if I want to do 100, 200, and I add, concatenate L1, if I run this, it just shows up in the front of the, element set. And like we talked about before, that lists are changeable. They're mutable. So you can mutate. You can literally change the elements within a set. You can add or remove. So let's do some examples here. So let's run our list, print list one again, original list. So let's say, like I said, lists are changeable and mutable. So if I want to change Eric, like I don't want to see the string Eric here, I want to see a number, for example. So how do I do that? So we know that Eric is is index, the second index, because, remember, 0, index 1, index 2. So this is only a 7th element, right? But what if you have like 20, 100,000 elements? How do I know the position of Eric, right? So all you need to do, if this was in 7th element, if I didn't know that this was, index number 2, this is what I do. And we'll talk about these operations a little bit, but I didn't want to skip this part because it's really important. So I just use the list name, variable name, dot index, parenthesis, and then I put Eric here. And it tells me that it's index 2. Now that I find that out, I want to change this string right here. I don't want to see Eric. I want to see, for example, 300. So I want to mutate this list right here. What I do is I put L1, that's the variable, index 2, which is Eric, make that equal whatever you want, right? So if I make that 300, for example, so then I print L1, then Eric is replaced by 300. So this whole list, this original list, which included Eric, I've changed it now. I mutated it. So I replaced the string Eric with the number 300. Okay? So let's do another example here. If you want to remove something, for example, or maybe not remove, but if I want to change, for example, these last 3 elements. So remember, to do the last 3 elements, you can do from, positive indexing or negative indexing or slicing. So I can do, for example, these last 3, I can do -4 or maybe -3 index to the end. Remember that? We've talked about it here, I think, somewhere here to the top. There you go. Yes, there you go. So if I print that, what happens first of all? So I'm printing the last 3. So if I want to change these last 3 to something else, due to the changeable nature of a list, so I put -3 to the end equals, something else. Let's say something that we can recognize, 600, 900. Print L1 again, then 99, A and B replaced by the new values. So pretty much you can play with it and see how you can mutate and change any variable that you want, any element that you want within the list. So let's talk about the different operations of list. So use L1 dot and then tab. It'll show you the different operations that you can use with with lists. So you have append, clear, copy, count, extend, indexing. We've used that a little bit there at the top to find out the index of a set of, an element within a list. Insert, but it pretty much works the same way. So a lot of these are pretty self-explanatory, so you can just understand pretty much by playing around with it. So remove meaning removing an element, inserting, appending. So let's just use each one of them as an example to show you what it is used for. So let's start with the first one, append. So if you append 9 to L1 and you run it, then 9 will be added at the end of that list. So let's use another one example, tab. Let's see clear, what that does. So clear will pretty much remove all the items from the list. So if you do that and print L1, it becomes an empty list. So let's see what else we have. But because we removed all the items in L1, we'll have to recreate it. So let's just use the same set as well. I like the sets. So 359, I could just copy and paste, but it doesn't matter, I can type it. 600, 909. So let's print that and make sure. Okay, so let's use another operation. We've used append, we've used clear. So let's see what else we have here. Copy, let's use copy. Okay, so copy. So essentially, copy, what it does is just return a copy of the list that you just created. So if I print L1, just similar to, I think we've used that. So it's just the same thing as what we've used before with the colon. So if you just use a colon like that and you print L1, it's going to print, it's going to copy. So it's the same thing really. So L1 dot copy is the same thing as L1 using the the colon. So it's just going to copy the same set of list. So let's run through the list again. So we've done append, clear, copy, count. We haven't done count yet, so let's do that. Let's see what it does. So count, what it does pretty much is just return the number of times a particular element appears in the list. So unfortunately, we don't have any repeat numbers here. But if I want to know how many times 300 appear in the set of list, if I run this, it's just going to tell me one time. But if I had 300 like 4 times, it's going to return 4. So that's what count does. So let's see what else we have. So L1, tab, extend. So let's try extend. So what that does is pretty much it'll just extend the list by adding the items from another list. So let's say we have another list here, and let's just add some recognizable numbers. So let's say 333, 222, just as an example. It could be anything. So if I want to extend L1 or L2, what I'm going to do is I'm going to do L2 extend L1, and if I print L2, this is what it does. So pretty much what it did is just added L2 to L1. This is L1 right here. So you just added all the items from the second list pretty much. Okay, so let's look at For example, what's next? So index. We've seen that earlier, but let's look at that again. So if our index is just going to tell you the position of a particular element. So if I want to know, for instance, instead of counting, this is index 0, 1, 2, 3, whatever. If I want to know the index of 500, then I'm just going to put 500 here. And I'm going to, oh, this is L2, by the way. So if I hit that, so this is position number 6, and we can easily verify that because the 500 is position number 6, index 6. Okay. All right, let's keep going. So let's see what else we have. Insert. So insert is just like the name indicates. It's just gonna insert an element to the list at a specified index. So let's say I want to insert like 111, for example, between index 1 here and index 2. What I'm going to do is I'll put, L1 or L2. L2, because we're talking about this new list right here. So L2 dot insert. So I want to insert it between index 1 and index 2. So it'll be the, index 2. So I'll put 2 here. And let's say I want to put 111. So let's print that. So it is inserted here, as you can see, at the second index, right? Because, this is, again, 0, 1, and 2. So be careful using this one here a little bit. It can get confusing. So I want to insert it between index 1 and index 2. So it's going to take the position of index 2. So that's what I will put here, essentially. Okay? All right, what's next? So we've talked about insert. So pop. Pop removes the item at a given index from the list, and it'll return the removed item. So I've inserted 111 here in L2. I keep putting L1, but L2. So if I want to pop that, this is what I will do. So you do pop, so index 2, right? Because 111 is index 2. We've seen that already. Is index 2. So if I run that, L2, you'll see that it's removed. So it's going to return the list with the removed item. Okay. So let's see what else we have. Remove. Okay, let's look at remove. So the remove function pretty much also removes the first matching element from the list. So let's see an example. Sometimes when you define these things, it's hard until you actually see what it means. So if I want to remove 500, then I'll just put 500, L2. So print L2. Nope. So 500 is gone. So the difference between these two is that this will using index. So this 111 is removed because when you use pop, use index, but when you use remove, you actually use the first matching element. So if I had if I had 500 here, another 500 here, it's gonna remove the actual 500, the first one. So the first matching element, that's what the remove function will do. Okay, so it's kind of similar though, pop and remove, but pop use index and remove use actual first element. So both will remove elements, but I guess just a little bit differently. So next is reverse. So reverse is just reverses the the elements of the list, right? So if I just use that L2, I keep putting L1, I don't know why. So that if I hit let me print L2. So it's just going to start from, just reverse it, right? So 900 all the way 3333 here. 333. All right. So last but not least, sort. So sort pretty much just sorts the element, of a given list in ascending or descending order. So if I want to sort L2, so this is in ascending order, the smallest value all the way to the largest value. And alternatively, though, if you want to, so this is by default ascending, but if you want to sort this in descending order, you will have to use reverse. So let's say this is what you do, L2 sort reverse equals to true. So if I print L2, hit that, so it's going to sort this in descending order, but by default the sort is ascending from smallest to the highest number. But if you want to do descending, use this reverse equals true function to sort this in descending order. So I think that's about it for the different operations here. I think we've talked about everything. So two things that I wanted to mention as part of this tutorial on list is the built-in function length, right? So I want to know, for example, how many elements are in this particular list, right? This is pretty short, but imagine if it's a little bit longer. So all you do is just use length, len, and just put the list in there that you want to know the number of elements in there, and then if you print that, it's going to tell you the number of elements within that particular list. And one last thing that I forgot to mention earlier was nested list. So if you want to create a list containing other lists, so we've had L2, and remember L1, let's print L1 here. So that's L1, let's print L2 now. If I want to add, or maybe not add, but if I want to create a nested list of L2 containing L1, so what I will do is just L1, I can use another variable. So let's just say L3 equals, L1 and L2. So if I print that, so it's going to add, so this is L1 and this is L2. So this is called, L3 is called a nested list. So that's one thing that I forgot to mention earlier. So I think that's it for the basics of Python list. So let me know if you have any questions or comments. Thank you.